Alright students, it's that time of the year again to get cracking on a test review because it's second semester. First test of the semester is coming at you pretty quick. But first we need to take care of some business. It looks like that the Math Republic, mathrepublic.com, has received its first piece of official fan mail correspondence here. It's from Edward Thomas, LA Compton City, California, 90220. Let's see what Edward has to say. Dear Mr. Russell, I like the respect right there. I've been watching your videos for as long as I can remember, and I respect and admire the way you do the math reviews on your website. Appreciate that, Edward. But I still have a question. I've been struggling with how to make math look as cool as you make it look. Any tips or suggestions would be welcome. Signed, Eddie. Thanks, Eddie. Good question. Appreciate the mail correspondence. Let me hit you with two pieces of advice. When doing math, well, first of all, I question the assumption that math needs to be made to look cool in the first place. But if I'm going to give you some advice, here's what I have to say. The first thing would be, when you do math, try to find the coolest pair of sunglasses possible and wear them while you do your math homework. This makes you look really cool while doing math. So for the duration of this review, I will wear these sunglasses because they look really cool. Second, try to talk in really extreme language while you do math. Make it sound just incredibly extreme. So, for example, you might want to say, alright students, it's time to do some inequalities. I'm going to hit you with some real talk right now. Test review number 7 coming at you. Alright, we have some inequalities here. And we will start by isolating x. Let's just activate my pen right here. Alright, we have 2 minus 2x less than 20. Solve each inequality, graph the answer on a number line. Looks like they provided some number lines for us. So, what we want to do, let's see what side of the equation x is on. I see that we have a negative 2x. So the first thing we'll want to do is we want to move anything else that we see on this side to the other side. And the way we do that is by undoing what's happening here. So I see there's a positive 2, so I'll subtract 2, subtract 2. This leaves me with a negative 2x less than positive 18. Divide by negative 2, divide by negative 2. X is greater than, look at that, that inequality changed direction. Oh, Mr. Russell, why did it change direction? Oh, well, let me answer that question. It's because we divided each side by a negative. If you divide or multiply through by a negative, that sign changes directions. 18 divided by negative 2 is negative 9. Now read this to yourself. This says x is greater than negative 9. So we'll drop a negative 9 on our number line. We'll draw an open circle as opposed to a closed-in circle. The reason we draw an open circle is because x can be greater than negative 9, but it cannot equal negative 9. And we will shade everything greater than negative 9. Let's take a look at number 2. 2m minus 1 is less than m minus 5. All right, I notice that there are m's on both sides of the equation. So what we need to do is we need to collect all of the variables on one side and all of the constants on the other side. So I'm going to start with my variables. I'm going to get all the m terms on the same side. So I'll subtract m, I'll subtract m, and the reason I subtracted m was to cancel out this m. So now 2m's minus 1m leaves us with 1m. I'll put a little 1 there if that helps you see it better. So we now have 1m minus 1 is less than negative 5. The inequality does not flip because we just subtracted. We did not divide. We did not multiply. Okay, getting pretty close. Now it's just a two-step equation here. I see that we have a constant over here. I'll add 1, add 1. Those ones will cancel. That leaves us with m is less than negative 4. So I'll draw my open circle at -4, and I'll shade everything less than -4. Alright, let's move along here. I'll do a little zoom out action here, get some there's a bigger page range into here. Alright, let's take a look at number 3. Number 3 looks like we got some fun ahead of us. We have some distributing we need to do. Whenever we see these parentheses here, this tells us this 2 is being multiplied by the g, and it's being multiplied times 3. So let's take a look at what that looks like. So I'll rewrite it. 7 plus 3g's is greater than 2 times g is 2g. 2 times positive 3 is a positive 6. Alright, I notice that our variables are on, they kind of have a split personality here. They're on either side of the equation. So we need to get them all onto the same side. What I will do is I'm going to subtract these 2 g's from that side. Those will cancel. But if I do it to that side, I got to do it to this side. I'll subtract 2 g's from this side. That leaves us with 7 plus 3g's minus 2g's is 1g is greater than 6. Getting pretty close. We just now need to get all the constants on the same side. We can do that in one move by subtracting 7. So I'll subtract 7 from each side. That leaves us with 1g is greater than 6 minus 7 is -1. So g is greater than -1. So I'll come up here to my, whoa, mouse is going crazy. That is really weird. Are you seeing this? You guys seeing this? My mouse is... So we'll draw an open circle right here at -1, and we will shade everything greater than -1 because g is greater than -1, but not equal to -1. Alright, let's take a look at number 4. So we have negative r over 3. We have negative r over 3 plus 6 is less than or equal to -4. Okay. What we see here is we see that r is being divided by a 3. And really, and don't forget about this negative sign here. And so we'll come back to that later. But first, let's take a look at this 6. We want to move this 6 to the other side. So I'll subtract 6 from this side. I'll subtract 6 from this side. Those 6's cancel. We're left with negative r over 3. I'm going to write it like this. Negative r over 3 is less than or equal to -2. Alright, now what we want to do is we want to do an operation that does two things at the same time. We want to get rid of this 3 that's in the denominator, and we want to change r to a positive number. So to do that, what we can do is we can do that all in one move by multiplying this side by the reciprocal of -1/3, which would be -3. If r is being divided by -3, then by multiplying by -3, we can cancel that out, and we also change that to a positive number. So we'll do that on the other side here like this. So now we're left with r is greater than or equal, because look what we did, we multiplied each side by a negative, therefore the sign flips. R is greater than 6, greater than or equal to 6. So we'll draw a closed circle at 6, and we'll shade to the right. Alright, let's continue on here. Let's take a look at number 5.